Hi, welcome to my video on the concept of mole. Chemistry is a practical science. It is very important for a chemist working in industry to predict how much product is produced in a reaction or how much reactants a chemist needs to produce a fixed amount of product. A good example is a chemical engineer studying rocket engine thrust. He needs to know the amount of exhaust gases produced. Or environmental chemist needs to know the mass of carbon dioxide produced when coal is burned. Or a biomedical researcher who needs to know the formula of an anti-cancer agent extracted from a plant. These questions can be answered by knowing formulas and the amount of substances involved. Stoichiometry, a Greek word that means part or element, is a study of quantitative aspect of chemical formulas and reactions. The central idea is the concept of a mole. 1 mole is equal to 6.02 times 10 to the 23 units. So 1 mole of sodium would be 6.02 by 10 to the 23 atoms. Or 1 mole of potassium phosphate is 6.02 by 10 to the 23 formula units. Or 1 mole of methane is 6.02 by 10 to the 23 molecules. 6.02 by 10 to the 23 is also known as the Avogadro's number, in honor of the Italian physicist Amedeo Avogadro. You must think of mole as a fixed number of chemical entities and has a mass. Atoms have fixed masses, and we use the mole concept to get a fixed number of atoms or any other chemical entity. The atomic mass unit numbers given in the periodic table is the amount in 1 mole, which in turn is equal to 6.02 by 10 to the 23. Now let's consider the following. If you have 1 mole of sodium, your periodic table will tell you that 1 mole of sodium has 23 grams, or you can think of it as 23 grams of sodium is 1 mole, which in turn it is 6.02 by 10 to the 23. If you worked out the molar mass of water, you'll find that the molar mass of water you obtain from the periodic table is 18 grams per mole. What this means is that 1 mole of water is 18 grams. And 1 mole of water is also 6.02 by 10 to the 23 molecules. Similarly, 1 mole of magnesium phosphate is 198.84 grams. Looking at the numbers in your periodic table, the atomic mass unit of magnesium is 24.3, is 3 magnesium, so 3 times 24.3 is 2 phosphorus, twice 30.97, and 8 oxygen, 8 times 16, and these numbers in the parentheses are given in the periodic table. So when you do your math, you get 198.84 grams per mole. 1 mole of magnesium phosphate is 198.84 grams. 198.84 grams is also equal to 6.02 by 10 to the 23. So how do we find the number of moles? Finding the number of moles from a given mass. The very first thing you need to do is go to the periodic table and get the atomic mass unit. And 1 mole would be equal to that atomic mass unit. And from there you can create 2 conversion factors. If you're finding the number of moles, you will use this conversion factor. You will multiply the mass by number of moles divided by the atomic mass unit. If you're looking for the mass from given number of moles, you will multiply the number of moles by this conversion factor, atomic mass unit measured in grams divided by 1 mole. To find the number of chemical entities, which basically is finding the number of atoms, molecules, compounds, or formula units as the case may be, the best way to do this is to create 3 boxes, mass, moles, and atoms, etc., in this order. Going from mass to moles or moles to mass, we will need the relationship between atomic mass unit and moles. And going from moles to atoms and vice versa, you will need the relationship between moles and 6.02 by 10 to the 23. So let's go ahead and create some conversion factors here. So going from mass to moles, you will multiply the mass by 1 mole over the atomic mass unit. And going backwards, you will multiply the moles by atomic mass unit, which is in grams, over 1 mole. Now, if you had moles and you wanted to figure out the number of atoms, you will multiply by 6.02 by 10 to the 23 divided by 1 mole. And if you had the number of atoms and you were figuring out the number of moles, you will multiply by 1 mole over 6.02 by 10 to the 23. I would now like you to pause your video and copy this down. You will need it for later. Let's consider this problem. How many atoms of silver are present in 0.0342 moles? The second part is how many grams of silver are present in 0.0342 moles. Let's go ahead and look at the second part first. In looking at the periodic table, we discover that the silver is 107.9 grams. In other words, 1 mole of silver is 107.9 grams. We typically call this the molar mass. And from there we can create 2 conversion factors. We want to figure out the grams from the moles, so we will use this conversion factor where 107.9 grams is actually in the numerator position. So using the given number of moles, multiply by the conversion factor and crossing out the units, we get 3.69 grams. Now let's go ahead and look at the first part. How many atoms are in 0.0342 moles? If we create our 3 boxes here and write down mass, mole, atoms in the order, going from moles to atoms, our conversion factor is 6.02 times 10 to the 23 divided by 1 mole. So that's what we will do. We will take the given number of moles and multiply by that conversion factor, do our math, cancel our units, and we get 2.06 by 10 to the 22 atoms. You notice that for the second part, where I'm figuring out the number of grams, we're going from moles to mass, and this is the conversion factor that we used. Let's go ahead and consider this problem. How many moles of carbon in 315 milligrams of graphite? I recommend that we do our 3 boxes here, mass, moles, and atoms. Identify the given box, and we have mass is the given box here. And the question is asking for moles, so we need to go from mass to moles. And going from mass to moles, we need to use the conversion factor 1 mole over the atomic mass unit. This is the conversion relationship here. 1 mole is 12.01 grams. So the conversion factor we will use is 1 mole divided by 12.01 grams. Doing our math, we will get 0.026 moles. I want you to notice that the mass was given in milligrams. It is very important to convert it to grams when we're doing stoichiometry like this. Find the number of moles and formula units in 41.6 grams of ammonium carbonate. Again, mass, mole, formula unit. Identify what's given, your given mass, identify what they're asking. They're asking moles and formula unit. So we can go from given mass to the number of moles our rule says to multiply 1 mole divided by the atomic mass unit. Very quickly consult your periodic table and figure out the atomic mass unit and multiply the mass times 1 mole over the atomic mass unit, and that'll give you the number of moles. If you need to figure out the formula units, take the number of moles given, multiply by the conversion factor, which is, remember, 1 mole is equal to 6.02 times 10 to the 23. Going from moles to formula units, you want to multiply by 6.02 by 10 to the 23 divided by 1 mole. So that's the conversion factor that we'll use, going from moles to formula unit. Again, the moles cancel out. Doing your math gives you 2.6 times 10 to the 23. How many atoms in 2.507 grams of potassium? Again, create your 3 boxes: mass, moles, atoms. Identify the given box. You are given 2.507 grams of potassium, and you're asked how many atoms. So this time you have to go to moles, and then from moles you have to go to atoms. Since they're not asking for moles, you do not need to pick up your calculator like we did in the previous problem and figure out the moles. Always start out with the given, and the conversion factor going 2 moles is 1 mole over 39.10 grams, because from our periodic table we know that 1 mole is 39.10 grams. In other words, 1 mole of potassium is 39.10 grams. Don't pick up your calculator because you really need to figure out the number of atoms. If 1 mole is 6.02 by 10 to the 23 atoms, then the conversion factor is 6.02 by 10 to the 23 divided by 1 mole. And that's the conversion factor we use here. Once you've set up your dimension analysis, it's really unit conversion if you think about it. Then you can cancel out your units. Plug the whole number in your calculator and you'll get 3.8 by 10 to the 22 atoms. Going from atoms to mass. What is the mass of 4.65 by 10 to the 22 molecules of tetraphosphorus decaoxide, P4O10? Again, create your 3 boxes: mass, mole, atoms. Identify your given box. This time, you are given some information on the atoms. What are they looking for? They're looking for mass. This is your question mark. So you're going to go from atoms to moles, and then moles to mass. Always start out with your given, 4.65 by 10 to the 22 molecules times what is the conversion factor to go to moles. If 1 mole is 6.02 by 10 to the 23, then the conversion factor going to moles would be 1 mole divided by 6.02 by 10 to the 23. Don't pick up your calculator yet. You have another conversion to do. The molar mass of P4O10 turns out to be 283.88 grams per mole. What this means is that it is 283.88 grams equals 1 mole. So going from moles to mass, you will use the conversion factor of mass over mole. So 283.88 grams per mole. And then you pick up your calculator and your final answer will be 21.9 grams. My final point is mass percent. Mass percent is really part over whole times 100 over 1. So if I wanted to find out the mass percent of phosphorus in P4O10, I know that 1 mole of P4O10 is 283.88. I got that from my previous problem here, using the atomic masses from the periodic table. The atomic mass of phosphorus in P4O10 is 4 times 30.97, which is 123.88. So mass percent of phosphorus is the molar mass of phosphorus in the molecule divided by the molar mass of the entire molecule times 100 over 1. The molar mass of phosphorus in the molecule, which is 4 atoms of phosphorus, divided by the molar mass of entire P4O10 times 100 over 1, which is 43.64%. This concludes my first video on stoichiometry. I'll see you again. Thanks for listening. Goodbye.